This module shows the application of MPLS-TP in a railway environment. Before we explain how MPLS-TP can benefit you, let's take a look at your world. A typical rail network has a vast infrastructure that needs to be managed. It's a complex combination of electrical and mechanical systems, including trains, tracks, track switches, stations. These systems can be divided into four major parts: control systems, communication systems, security systems, and information systems. In the past, only voice-related applications were networked. This was done via an SDH SONET network. Soon, communication would be the heart of the railway system and would interconnect the different elements to centralize control units or control centers. Let's see how this gradually evolved. IP made its introduction in train stations. These were mainly network computers with applications connected to them. The control systems, like signaling, were handled locally. These first IP applications formed islands of IP clouds in railway infrastructure. Next came the need to network the TCP/IP applications. Passenger information systems and network CCTV were interconnected and controlled from central locations. More and more new IP applications found their way into stations. New standards to control the railway traffic were introduced, resulting in a consolidation of signaling and interlocking. These first IP interconnections were done via IP over SDH SONET. Signaling and interlocking were backhauled over the existing SDH SONET network. The amount of IP network points and applications kept growing. More applications were managed remotely from a central location and needed to interact with other stations. As part of a global initiative, rail operators deployed GSM-R to improve safety and overall communication along the tracks. But the bandwidth required by IP became so large that its own network was required. By taking the IP part out of the SDH SONET cloud, capacity was freed up which could be used to backhaul GSM-R. IP network technology in control and security has been growing over the last decade and continues to do so. Many rail operators have therefore opted for an IP MPLS solution. The IT department starts to become an operator for their internal clients, like infrastructure, rail operators, etc. With the constant migration to IP Ethernet and the adding of new applications, the multiple communication services sit on a single network. The network becomes an essential part of the railway infrastructure, and the question is how to handle this with limited budget and resources. The signaling and interlocking will be run over IP and will be even further consolidated. The demands on the network continue to increase. Would you answer the challenges by increasing the IP MPLS cloud? Removing network layers by introducing IP MPLS has reduced capital expenses, but expanding the IP MPLS network across the railway infrastructure has increased operating expenses. The increased complexity comes from the different dynamic protocols which run in an IP MPLS environment. These are needed in dynamic environments, but in the static environment of an aggregation network, they are overkill. To reduce complexity while still offering the benefits of an IP MPLS network, the industry together with IETF and ITU have developed a new standard which is called MPLS-TP, or Multi-Protocol Label Switching Transport Profile. This evolution of the MPLS standards adds extra features which were previously not there, like bidirectional paths, the fact that you can run the network from a management system and in-band monitoring features. This evolution of the standards guarantees interworking with existing MPLS equipment, because it uses the same MPLS forwarding and pseudo-wire infrastructure already available on the market for years. Since the SDH SONET is nearly end of life, what will the future look like? MPLS-TP is able to provide you with the flexibility to manage and maintain your whole network for years to come. Let's now summarize the benefits of MPLS-TP to see the advantages of this new standard in the rail network. MPLS-TP networks are centrally provisioned through a management system and support static NMS-based provisioning. MPLS-TP networks support APS to secure fast failover times in case of failure of the active path. MPLS-TP can guarantee reconfigurations in less than 50 milliseconds under all circumstances. MPLS-TP comes with a powerful set of OAM fault management and performance monitoring features. It allows you to monitor services and engage in proactive and easy fault location to limit your downtime. MPLS-TP uses standard bidirectional switched pairs of paths which are co-routed up front. This ensures minimal differential delay which may occur in an IP MPLS environment. The popularity of SDH Sonnet is largely due to the high level of interworking between different vendors thanks to standardization efforts. MPLS-TP uses the same forwarding mechanisms already available on the market, so it guarantees interoperability with IP MPLS, Sonnet and SDH. You benefit from transparent networks which are future-proof. The characteristics we've just described explain why MPLS-TP has become so popular with the industry and telecom operators. MPLS-TP satisfies all the typical service requirements in an aggregation network of a railway customer. It's packet-switched, future-proof, cost-effective and fully interoperable. MPLS-TP, a solid foundation.